Hello everyone, my name is Dan Croucher and I am the Senior Marketing Manager at Unchained Labs. I will be your moderator and thank you for joining us today. We'll have a Q&A session at the end of the presentation. To ask questions, all you have to do is click on Q&A in the Zoom navigation bar at the top or bottom of your screen and type your question. When submitting a question, please avoid clicking the anonymous button, so then we can reach out via email if we aren't able to get to your question, but we will get to as many of them as we can today. So now I'd like to introduce Joanna Winkler. She is a Marketing Application Scientist at Unchained Labs, and today Joanna will walk us through how to use Uncle to test protein stability in thermal ramp experiments and with the new isothermal and out-of-the-box applications for Uncle. She'll present data from 2 proteins in several formulations. So now I'll hand it over to Joanna. Good morning, Joanna.
Good morning, Dan. Good morning, and thank you for the introduction. And I will share my screen now. Here we go. So I'm super excited to tell you today about how Uncle can help you assess the thermal stability of your proteins. How is the protein stability verified? Well, researchers often use thermal ramp experiments. Why? Because it's fast, has a very good throughput, and yields informations like melting temperature, the Tm, and aggregation temperature, Tagg. These allow to rank and sort investigated candidates. However, thermal ramps are not designed to do the long-term exposure to high temps and tell you how it affects the proteins. This is a familiar picture, right? I'm pretty sure that it happened to majority of us at least one time that we stayed too long at the beach and it ended up in the sunburn. Personally, it happens to me too often, and I'm always upset that I didn't learn my lesson and didn't use a sunscreen. Likewise, if you know how your biologic reacts to long-term exposure or storage at elevated temperatures, you can take precautionary actions. So isothermal testing is all about keeping your analyte at the constant temperature and recording how it performs. In Uncle, you can monitor many samples and their behavior in parallel. Often the long-term testing is included in the later stages of the biologic development. And why? Well, it's because the old school isothermal testing like HPLC is labor and instrument intensive, so does not exactly fit in the early screening of the candidates. Also, the accelerated stability is not exactly that fast. The risk with waiting too long with these tests is that the candidate may turn out to cause trouble later in the development. Today, I want to tell you about the hassle-free isothermal testing using Uncle and how it fits into the stability assessment of proteins. But let me say it right now. Unlike the sunscreen, it's not sticky and you don't have to apply it every 2 hours. The new isothermal apps on Uncle allow you to test long-term stability earlier in the candidate selection process in parallel with thermal ramp experiments. In protein stability, there are 2 phenomena that we need to be aware about. There is a constant equilibrium between the native and the unfolded state of the protein. And this is what we call conformational stability. Moreover, both native and unfolded state can also aggregate. And then we are talking about the colloidal stability. And these 2, conformational and colloidal stability, need to be kept in mind while studying overall protein stability. Sounds complicated? Well, Uncle can tackle all of this. It's a stability platform and the right tool to study protein stability. It combines measurements of the full spectrum fluorescence with a 266 nanometers UV laser for intrinsic fluorescence and 473 nanometer blue laser for label or dye-related fluorescence. It also has the static light scattering analysis, the SLS, to provide you with the insight into the aggregate formation. and also the dynamic light scattering, the DLS, to look at particles' diameter and polydispersity index. And all of this happens in the temperature-controlled environment from 15 to 95 Celsius degrees. The magic secret of the UNCLE is the UNI, a sample holder made of aluminum frame with 16 quartz cuvettes holding 9 microliters of sample each. All you have to do is to pipette your 9 microliters of sample in and place UNI inside its blue frame. So the silicone seals the clip around the quartz cuvettes. So it means that your samples are perfectly sealed, and you don't have to worry about the evaporation over long periods of time. Okay, so let's see how the raw data of UNCLE experiment look like. UNCLE reads the full spectrum fluorescence of protein sample as temperature increases. So each line in this graph is the fluorescence read of a protein excited with 266 nanometers laser, starting at 15 degrees and going all the way to 95 degrees. One spectrum corresponds to a change of 1 Celsius degree. As you can see, along with the increasing temperature, the maximum intensity decreases. And the spectra slightly shift to the right, meaning the longer wavelengths. And this phenomena is called the redshift. And it happens due to the aromatic residues fluorescence shift as they move from hydrophobic environment inside the protein to hydrophilic environment of buffered solution. After reviewing the raw data, what is it turned into? This graph shows that the protein is measured in changing temperature for unfolding with the fluorescence in blue and for aggregation with SLS in green. The measurements are done simultaneously. UNCLE analyzes the fluorescence as barycentric mean wavelength, which is a spectral center of mass. An advantage of using BCM is that it takes 130 wavelengths into account and yields very robust signal-to-noise ratios. As the temperature increases, the protein unfolds and the fluorescence emissions shifts to longer wavelengths, and consequently the BCM increases. The points we are interested in are the inflection points because they reflect melting temperatures, Tm1 and Tm2. Software finds the Tms by determining the first differential maximas. As for the aggregation, the plot is flat and steady until approximately 80 Celsius degrees, and then increase in SLS indicates the aggregation onset. And in this example, aggregation happens in concert with the second melting point. Both conformational and colloidal stability are monitored at exactly the same time, exactly same temperature in the same sample. Let's look at the example of monoclonal antibody in 3 different formulations in thermal ramp experiment. The monoclonal antibody is in 25 millimolar histidine buffer at pH 7.4 with no salt in green, low salt in blue, and high salt in yellow. The Tm values indicated by the arrows differ a little bit between the 3 formulations, and high salt is the least stable one. So let's add the SLS information, the dashed lines. For the T values, we see bigger differences between the formulations. Low salt is clearly the least stable because we can see the aggregation at approximately 66 degrees. And also there's not much difference between the no salt and high salt conditions, as they show aggregation at approximately same temperature, 72, 73 Celsius degrees. However, UNCLE has DLS, which allows an independent look on aggregation. Here, there are shown only no salt and high salt conditions, and DLS clearly confirms that the sample aggregates. Before the thermal ramp experiment, the particle diameter is approximately 10 nanometers, while after the thermal ramp is above 1 micrometer. After analyzing the ramp results, let's see how our antibody reacts to the isothermal treatment. In other words, in uncle, in his isothermal experiment, we monitor the fluorescence for unfolding in this graph shown in blue, and SLS for aggregation in green, as a function of time and simultaneously. The big question when considering an isothermal is which incubation temperature to choose. Often it's 40 or 45 degrees are these temperatures have always been used, but then you might not see much. So uncle can improve this process and help you find the right temperature, because it's so easy to set up a bunch of incubations in series and find the one for the longer testing. In our case, we have chosen 60 Celsius degrees, and it's well below the Tms and Taggs. The isothermal, and we are focusing on SLS 266 here, we see that the low salt formulation, blue line, aggregates first. And this confirms what we saw in the thermal ramp experiment. Also, for no salt and high salt formulations, the Taggs are pretty close, but the isothermal test allows to spot a clear difference between the two. And the no salt seems to be the most stable formulation here. Here we look at SLS at 473 nanometers, and it confirms what we saw one slide before, that no salt is the most stable formulation. As isothermal in uncle also will yield a rate constants to quantify samples behavior, we can also see that no salt formulation has the highest K value. There is one major downside of isothermal testing, which is, well, it's all about the long-term exposure. So during that time, the instrument is occupied for a while. However, we added OTB, out-of-the-box application, which allows to incubate analyte in the uni, in the incubator, as it's safely sealed in it. So we can take out the sample in the uni out of the incubator and then monitor this data point in uncle. And it's up to you to choose the intervals and the frequency of the measurements. Here's an OTB result for SLS using 473 nanometers laser for our antibody. And the readings were done at 0, 20, 40, and 60 hours. So it's consistent with what we saw before, that the low salt formulation leads to more aggregation than the high salt. You can gather this data while uncle will be free for 20 hours between the reads. Just like other isothermals, the OTB experiments let you record DLS, the DLS. So here we can see the comparison of monoclonal antibody in the low salt conditions, which was stored in the fridge at 4 degrees or at 60 Celsius degrees. We see no increase in the hydrodynamic size at 4 degrees, but the size increases over time at 60 degrees. And this confirms that aggregation indeed happens at elevated temperatures. To summarize, for our monoclonal antibody, all the aggregation metrics agree. No salt formulation is the best, and low salt is the worst. All this data was recorded with one instrument, and it shows how amazingly flexible it is. But uncle has the tools which are applicable to any protein, not just monoclonal antibodies. And I want to show you an example of another analyte, which is a little bit more complicated. We have chosen a small enzyme that has a very few aromatic residues, therefore intrinsic fluorescence won't work. You can see that in the left graph, which compares the fluorescence of this enzyme we have chosen, RNase A. In its fluorescence is shown with the green line, and then with the blue line is the monoclonal antibody fluorescence we showed before. As uncle records the full spectrum fluorescence, you can use a reporter dye like Cypro Orange in cases like this when analyte has no or few aromatic residues. And Cypro Orange will bind to a hydrophobic regions of protein as it unfolds, and this will lead to increase of its fluorescence, as you can see in the right graph. With Cypro, we see nice thermofluor melting curves, but there is no difference in three conditions in the thermal ramp experiment. RNase A is also not aggregating in these conditions as SLS indicates. However, when looking at the long-term stability, we see that RNase A does in fact aggregate, but it takes at least 10 hours to see that. The SLS 266 signal increases in no salt and in green and low salt in blue conditions, while only the high salt prevents aggregation, as almost flat line shows here. Trying DLS out of the box for RNase A confirms here too that the hydrodynamic size of particles increases after approximately 1 day in low salt and no salt conditions, and only high salt prevents the aggregation. So the RNase A is an example of an analyte when we would have not been able to rank its stability in 3 different formulations via the thermal ramp experiment only. And we need isothermal experiment to get a full picture of this analyte stability. We can study all these behaviors and many more using UNCLE, the first all-in-one stability platform. The three detection technologies in UNCLE are combined to a long list of over a dozen applications that help you solve a wide variety of stability and characterization problems. So UNCLE can help you solve problems from candidate screening with or without dyes in thermal ramps or isothermally, colloidal stability in formulation work, to isothermal chemical denaturation, and you can also use it to characterize the viral vectors. Take-home message is, UNCLE is your protein's lifeguard. No matter if it's just 2 hours thermal ramp or a full day or more in the sun. It will tell you when to slap on the sunscreen and will keep all the samples under his eyes and safe. With that, thank you for your attention, and I will be happy to take any questions.
Thank you, Joanna, for taking us through how you can use UNCLE to check conformational and colloidal stability of proteins in thermal ramps and detect TMS and Tagg, how to study proteins that have low intrinsic fluorescence, and how to look into long-term behavior of proteins using isothermal and out-of-the-box apps, a test that adds important stability information to what we learned in the ramp experiments. So we have some great questions that have already been submitted. Don't forget, you can still ask a question by entering it in the Q&A section of your Zoom navigation bar. So let's get started with the first question, Joanna. How flexible are the new isothermal apps in UNCLE?
So it's very flexible, and there are several aspects of that. So first, the isothermal combines the fluorescence, static, and dynamic light scattering, and it allows the user what do they want to choose, what do they want to look at. Second, isothermal app allows full user control of the sample, excitation, and emission analysis range. Applications isothermal with Cypro and isothermal capsid are also specifically tailored for these 2 respective systems. Third, out-of-the-box application adds another layer of flexibility, as you can use the sample, as you can use your UNCLE while the isothermal incubation is running outside of the instrument. And finally, our analysis algorithms are very flexible. There are 3 fit models to be able to describe different protein behaviors during the incubation.
Great, thank you very much. So the next question we have is, can we use isothermal apps to study AAV and other viral vectors?
Yes, the isothermal capsid stability is the isothermal sibling to capsid stability. So it allows monitoring of genome ejection and capsid aggregation during the isothermal incubation.
Okay, thank you very much. The next question is, are there any other changes introduced in the new software?
So we included a couple of changes. There is a user feature request in the release, and we gave the software a facelift. So there are replicate groups now. The color assessment was redone. Also, the DLS data display is more clear. And we also have added advanced analysis and more apps.
Awesome, thank you very much. Next one is, when would you use a reporter dye?
So you have to use the reporter dye in case that the protein does not fluoresce by itself. And this could be because it is low in aromatic residues, or in cases when the formulation is quenching the protein fluorescence.
Great, thank you very much. Another question we have is, does Uncle have tools for 21 CFR 0.11 compliance?
Yes, Uncle has tools to help you with the GXP compliance. So we offer a 21 CFR 0.11 and as an add-on for the software, and also qualify the instrument.
Great, thank you. Another one we have here is, can you use a uni for several tests?
Okay, so this is a yes and no answer. The cuvettes and uni are designed for a single use, because that way you always will have the highest quality optical system for your work, and you don't have to worry about removing the naturated protein. But unused cuvettes in the same uni can be used as long as the whole uni is fully done. And you also have to remember that during one test, you measure many different parameters. So actually, effectively, you are running several tests at once.
Great, thank you very much. We do have a couple more questions here in the Q&A, but unfortunately, we are quickly running out of time. So like I said at the beginning, we will get to everyone who has asked a question via email. I'm sorry if we can't answer it today. But thank you for answering all these great questions so far today, Joanna, and thank you again for a great presentation. I also want to thank all of you who joined us live today. And if you would like to have a deeper conversation with our team, please do get in touch with us at info@unchainedlabs.com, or learn more at our website at unchainedlabs.com. We would love to connect with you. Thank you again for attending our virtual seminar, and I hope you have a great rest of your day.
Thank you. Bye.
Bye.